Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode, we're gonna take a look at online UPS or double conversion UPS. So let's dive right into it. So first you have to understand why there is a need for something so complicated. You have to understand what if your electronic is so expensive. It's very expensive electronics like 4K television, your super fancy Dolby Digital audio sound system, your 4K media player, your home theater PC, and like let's say if you have something so expensive, it is justifiable to spend a lot of money to make sure they are protected. And let's say you are in a scenario of like IT industry where you have servers of it, they are quite important, and suffice to say if they go down for even a moment you could lose a lot of money, and heck you can even compromise security in some scenarios. So suffice to say, if you have something known as mission critical, what does in mission critical scenario you need to have something like this. And then you have to understand, like many hospitals also use it, like you have life support. You cannot have a scenario where life support goes offline. So suffice to say, it's quite dangerous if that happens. And there are things like this happens all around the world where you have a scenario where you cannot afford to lose power, like ATMs or broadcast systems, or anything like that. Servers are very popular with these sort of things. So what does this double conversion do? This red point, it does power conditioning. So basically in that one unit you get stabilizer, you get constant voltage transformer, you get surge protection, you get low voltage cutoff protection. Like entire power that is coming out of your online UPS is stabilized to a point where there is no fluctuation, no matter what happens to your grid. It goes down, doesn't matter. It goes over voltage, doesn't matter. It goes under voltage, does not matter. So this whole factor that power conditioning is done because of it, it saves a lot of money elsewhere in the system. Imagine like you are running a bank where you have like 10-20 computers. Instead of getting UPS for each one of them, you only have to have that. Or let's say you are running air conditioning on top of that, you don't have to worry about like getting a stabilizer for each air conditioning. You save money in that way and simplify your operation. So suffice to say, it's kind of complicated, and this is my rough, please understand, it is a rough attempt to explain online UPS. And I have seen a lot of diagram, but they kind of neglect or sometimes flat out omit quite important sections. So this is my attempt to explain what the hell is happening in the first place and why it's called double conversion UPS. So first you get mains power, obviously it comes into it, then it goes through filter. Now filter is not necessary, and heck even old UPS did not used to have that. It's kind of modern thing. They do what's called power factor correction. So without that your generator will have hard time driving these things. And a lot of other things like inductors, capacitors, to like basically filter things out. From there it goes to rectifier. Now rectifier makes AC into DC. It can be done in many ways. It can be done via pulse width modulation, or it can be done by simple bridge, full bridge rectifiers. Then you get an output. Now understand this rectifier is very overpowered. Let's say this whole system is rated for 10 kilowatt. This puppy has to be rated for much higher than that. Now that higher depends on the battery bank. So that rectifier has to provide power for the whole system plus the power that is needed to charge the battery. So let's say battery has the C of a battery is generally smaller than the D of the battery. Basically discharge rate is kind of very high for batteries. You can discharge battery at like 20-30 amps, while you can only charge them at 5-6 amps. So suffice to say, the C plus the overall load equals the outcome of this rectifier. Now it does not mean that it's giving out that much all the time, but it has to able to handle that 24/7. Now so from that you get DC output. Now DC output goes to CC, charge controller. Basically this was also not present in very old UPS. Suffice to say, it will fry your battery if it does not have it. Like the fluid that you have in your battery will evaporate very quickly if you have putting in constant amount of current, and it's not advisable. Your batteries will not last long. So charge controller handles a lot of things, like it monitors the state of charge of your battery, like because if battery is 80% charge, it takes amount the charge goes down. If it's like almost fully discharged, the charge goes up. So charge controller controls these sort of things, where you have how much amp should be put into the battery bank. It controls it, and it also has sometimes temperature sensors, sometimes on the battery bank, sometimes just as an ambient sensor. So if environment starts to reach higher than, let's say, 30 degrees Celsius or 40 degrees Celsius, it will start to tone down the amp, so it does not hurt your battery. So that's why charge controller is there. Now this rectifier output goes to DG. DG is like, this is the top secret or like patent part of all the systems. This is where the switch is in online UPS. Now when people say online UPS is always running on battery, no, that's factually impossible, practically idiotically stupid, because batteries are not capacitors. They because of their nature, you have to separate them while charging and discharging. So charge controller gives the output to the battery bank is charging up. Battery has a power going into this diode gate. Now this diode gate, you have to look it up for yourself. Like, suffice to say, I tried to understand what it is. It's kind of complicated, and the best I can guess is like there is two input and one output, and there is one primary. So if primary cuts out, then only the second goes in, and there is no delay in the situation. So you are always getting from your rectifier or you're from your battery, so you are always running on DC. So this diode gate is the one that is trade secret, or like sometimes they call it buck topology or things of that nature. So you have to understand. So if power cut happens, like if your rectifier goes down, this DG will directly allow you to connect your inverter to the battery. Now, so while you have charge controller handling the battery, once, let's say, main fails, the battery directly, because of this, there is no switching delay. It is directly goes into your inverter. Now this inverter is a sine wave inverter. So how does that sine wave inverter thing work? It's very simple. It just have IGBTs and lot of pulse width modulation signals, and that also helps it to make sure the voltage output is always constant no matter the state of charge of your battery, because as many of you know, the battery loses its voltage as it gets discharged. So let's say when your battery is fully charged in a lead acid battery, it could be as high as 13 to 14 volt, and when it's getting discharged, it could go as low as 10 to 8 volts. So suffice to say, you have to compensate for it. Pulse width modulation allows them to very easily tone down the voltage. Basically, the width of the pulse, they can simply like, okay, if the voltage is too high, the pulse will be kind of tight, and if the voltage is low, they can broaden the pulse width basically. And to handle that, they will design the transformer that goes here after the AC. Like, let's say you are making a 12 volt system, you will specifically design it so it directly runs on 10 volt, basically the cutoff voltage of your battery bank. So the transformer is capable of lifting up that voltage to the full output. So if you mention old UPSs and especially inverters, square wave inverters have this horrific tendency. As the battery goes down, you can almost see everything becoming dim, lights becoming dim, fan becoming slow. That is not acceptable with this. So for this reason, the transformers in these things are generally designed to work at the lowest voltage level possible for the battery bank. So let's say the battery bank is 96 volt, and they, let's say, just for a comparison, let's say it can go down to 85 volt safely. So they will build the transformer from that voltage. And this is one way. There can be 10,000 other ways. This is one way that I found they handle it. Now, you get the inverter. Inverter is doing the pulse width modulation. After that pulse width modulation, that AC signal is go to the transformer. Now this is where you get your isolation. This is where the power conditioning actually pays off, because there is no direct connection from in to out. Nothing goes through here. Like like no matter what kind of fluctuation you have in your mains, it does not transfer here. This is what's called galvanically isolated. Basically, this is completely isolated for all electrical reasons. And some UPSs have, almost all have, a fault detection where if, let's say, this unit fails, they will have a static switch that will bypass the UPS. So even if the UPS fails, you won't have like complete fail. All it will do is simply bypass it to mains. Or sometimes they could bypass after the filter, because generally filter are a thing that don't break down that easily. So they can directly bridge from here, or sometimes there could be just a manual switch that if your UPS goes down, you flip that switch and you can disconnect the UPS and maintain it. So this is the whole process for it. So a quick summary: you have filtered, You made AC into DC, you feed that DC into inverter plus the charge controller, and it goes through a diode gate, and when the power goes on, diode gate directly bridges the battery to the inverter, and from inverter you get to a transformer which galvanically isolates your whole thing, and you get a stable load output. So this is the whole idea of double converter. Because you are always running on DC and inverter is the one that is controlling your frequency, your voltage, there is no fluctuation. Ideally, like of course there will be minor fluctuation here and there, but ideally it's so low that all high, all components can last very long. So this is the whole topology. Now I have to understand, if this is so good, why the heck it's so expensive? Of course, their need would be so high that it should be cheap. But you have to understand, these are designed to run 24/7 into 365 basically, and that should also run as long as their warranty is there. So suffice to say 3 to 5 years. The reason for that is it never ever turns off. There is no off. Like your UPS, the very old UPS style that we used to have, simply bypass the mains. So the rectifier stage will only work as long as it needs to charge the battery. Once the battery is charged, it's cut off. Here it has to work 24/7. As long as any load is connected to the UPS, it has to work. So that is a very big problem. And a rectifier also has to be overbuilt. It's like full load plus the charger load. So over there. And inverter also needs a feedback loop. Generally sine wave have it, but it's also kind of compulsory for sine wave, compulsory for online UPS, because without a feedback loop, the pulse width modulation cannot be controlled properly. So it cannot guess. It has to know the voltage that is sending out. Let's say is 220 volt. It has to be 220 volt. It cannot be 210 volt or 230 volt. It has to be 220. And they will generally give you a very tight range. So you don't need any stabilizer, you don't need any UPS or CVT or anything in your products. So one thing I want you guys to take away from it is that power and capacity of this sort of thing is completely independent. Second, the reason why all the UPSs are rated in kVA rather than kilowatt hour or amp hour, it's very simple. kVA is independent of power factor. Depending on the load, each object, like let's say a jet pump or a tube light, even though they could be rated for same wattage, they will have different power factors. Based on that power factors, their power consumption actually varies a lot. So that's why they generally use kVA, and also kVA is generally bigger than kilowatt. So 30% lower is a very good idea. It's a safe bet. So let's say you get a 10 kVA UPS, only put 8 kilowatt of it, 8 kilowatt load. Don't put 10 kilowatt load, you will fry the UPS. Second, how long will it run? That's directly proportional to the battery size. Now you might say, okay, it says 24 volts, so that means 2 battery. Again, in 2 battery, what amp hour? You can have as low as 7 amp hour to 220. I just bought a inverter and those batteries are idiotically expensive. My UPS is cheap, but that batteries are expensive. So be mindful, these two things are quite independent. So there are Microtech UPS that is quite cheap and pure online, but and it also has 6 batteries. So you'll be like, oh, this is gonna run for hours, but battery capacity is barely 800 watts. So suffice to say, it will only, if you have a 4K TV, it will only run for 2 hours at max. So suffice to say, this was my presentation of online double conversion UPS. I hope you like this presentation. In that case, please like. If you didn't, dislike. Leave a comment and tell me what you want to see next in Computer Wednesday. And as always, subscribe, press the bell icon. I make video every day. And thanks for watching.